You want to create your first application in MICROSAR IO and want to know how to speed up your development workflow with our super easy tooling? Then, let's go! Hi, I'm Florian, and I want to show you how to configure, generate, and implement an application MICROSAR IO, and how to upload it to a hardware platform. MICROSAR IO is fully integrated in Visual Studio Code. This means configuration, generation, and implementation take place in the same tool. So, let's open VS Code and start right away. Creating an application in MICROSAR IO is super easy. At first, go to the configuration folder and open the application framework.yaml file. In this tutorial, I would like to develop an application that makes an LED blink. Now, the list of the applications is empty, and we must add one. To make the configuration easier, auto-completion support is provided by just hitting Ctrl and space. First, we set the name of the application. Here, My LED App. Next, we need an initialization function to set up the LED pins. I press Ctrl and space, select the attribute init functions, and add the name of the function. Here, My LED App init. Our LED should blink every 500 milliseconds. So next, we create a cyclic function. For this, we configure a cyclic function group with a cycle time of 500 milliseconds. And the name of the function is My LED App main function. And we're done. Oh, wait, almost forgot. We have more features. With a mouse, we can hover over the configuration attributes and get a helpful description. Here, we can see that the unit of the cycle time is milliseconds. Okay, and that's it. Everything is configured. Now, we can trigger the code generation, and according to our application framework.yaml file, we get a C file for the application. For this, we go to the upper right corner of VS Code and trigger the build process, which also triggers a generation. This takes a little bit of time. After that, we open the code folder and navigate to user code. All the files listed here can be modified by the user. Under AF, we see the application framework myledapp.c file. Here, we implement our code for toggling the LED inside of the generated user code sections. I have prepared some code as it depends on your hardware. At first, we add an additional include to get all the hardware-dependent functions. Then, we define variables necessary for the LED pins. To initialize these pins, we go to our init function and add the code for setting up the LED pins. The code for toggling the LED we put inside the main function. And finally, we trigger the build process once again to compile the application. Now we have finished the implementation of our LED application. Next, the code must be uploaded to the hardware. MICROSAR IO is compatible with different hardware platforms. For our demonstration, I use this little board. This board has an onboard debugger, and I just connect it via USB-C to my PC. That's pretty easy, right? Back in VS Code, we go once again to the right upper corner and trigger the upload. In the log output, you can see the upload process, and it ends with success. The application was uploaded to the hardware, and now we see the blinking LED. Okay, we have already finished our application development. That was much faster than typical automotive development workflows, don't you think? Do you want to try out MICROSAR IO yourself? Get in touch with us and download your free evaluation bundle. The link is in the description. I'm sure MICROSAR IO set you on fire. If you want to see more cool vector products and tutorials, subscribe to our Vector Tech Tutorial YouTube channel. Activate the bell and see you soon!